So, welcome to the first lesson in what I call life support systems. These are the systems that an engine needs in order to survive. Now, there are 6 main systems that you're likely to encounter when you're looking at internal combustion engines. These are oil, fuel, water, air, exhaust, and the electrical system. Some engines have more than 6 systems and some engines have less. Lubrication oil, fuel, air and exhaust, those systems are always going to be present to some degree. Sometimes for very small engines, you'll actually mix lubrication oil in with the fuel itself, although that is only for very small 2-stroke engines. So let's look at the lubrication oil system first, because arguably it's the most important system in the engine. I've loaded this 3D model up. It actually shows the lubrication oil system, and it's highlighted with these orange colours. You can see that lubrication oil is pumped all around the engine. It actually sits in the base of the engine here. This is what we call the oil pan or the oil reservoir. We then use an oil pump. That is this item here, and the oil pump will pump the oil around the engine, and you can normally see the oil pressure on this section here. We have an oil filter that is represented by this filter strapped onto the side of the engine, and that will filter out any impurities that are within the oil. Bits of metal, bits of sand, bits of dirt, anything that might be in the oil that we don't really want to be circulating around the engine. Now you might wonder, where are these bits of metal coming from? Well, they're always going to be present, very small shavings, sometimes from bearings and other engine components. And if you're cleaning an oil filter, you'll notice them because they feel a little bit like sand or grit when you rub your fingers together. And those pieces are just essentially bits of metal or bits of sand, dirt and things like that. So we want to filter those out, because if we circulate them all around the engine, what we'll actually be doing is pumping these bits of sand and metal into places such as between the bearing and the crankshaft, where they're going to cause damage. The clearances between the bearings and the other machinery components in the engine are very, very small. So anything that gets into these spaces is most likely going to damage the metal. Sometimes you'll actually flake off a bit of a bearing, for example, and then that falls into the oil system as well, and it's a cumulative effect. So that's why we have our oil filter. We can actually see on this engine that we have some gearing here associated with the camshaft. Looks like it's geared and hooked up also to the crankshaft and the oil pump. The oil pump is driven from the crankshaft itself as well. But what we're mostly interested in for this lesson, rather than go through and analyse the entire lubrication oil system, is the fact that the oil itself is responsible for cooling and lubrication. We send the oil to all the areas of the engine that move. In other words, if the rocker arms are moving up and down, they're pivoting, we can see we're going to need to supply oil into this area in the rocker arm, and we're going to press the oil out all around this inside of the ring so that when they operate, let's just see that occurring, maybe we can. You can see one in the background there spinning. If that was spinning on a metal surface directly, we'd have a lot of friction and a lot of heat. So in order to get around this, we actually lubricate the inside, and that reduces the resistance and friction, which means we generate less heat with all of this movement. What you have to understand though is that the rocker arms are the least of our worries. These are relatively lightly loaded and they're not going to generate a huge amount of friction. However, when we get down and we start looking at the pistons, the crankshaft, the camshaft, you can see the crankshaft rotating right now. They all need to be lubricated, because if not, the engine will overheat very, very quickly. And when it does, you run the risk of having thermal expansion. That means the components all get larger due to this increase in temperature, and the engine may stall. And if that happens, then you'll have to wait for the engine to cool down again before you can operate the engine. We actually call this seizure, or sometimes you'll hear people say that the engine has seized. So there are two main purposes of lubrication oil. One, to lubricate and reduce friction, and two, to remove heat. The oil returns back to the oil pan or the oil reservoir in the base of the engine, and there it's going to be cooled. Imagine for a moment that this engine was attached to a truck. You can see on the bottom here we have these squiggly shapes all along here. They allow heat to be transferred to the air very efficiently. So if this engine was mounted in a truck and the truck was travelling forward, such as in the direction we're travelling now, then the air is going to be passing across these fins, these cooling fins, and we're going to be cooling down all of the oil in the oil pan. If we do that, then that means that the oil temperature will reduce, and when we recirculate it around the engine again, we're not going to cause the engine to overheat. Obviously, if we slow the engine down, it means we're not travelling as fast anymore in our van, which means we're not getting as much air passing over these cooling fins. But that makes sense because we're not normally going to sit and rev the engine for half an hour and not actually move the vehicle. So when the engine is working harder, there's more air passing over the oil pan and cooling down the oil. And when the engine is not working as hard, there is less air passing over the oil pan and cooling the oil. But then the oil is not as hot because the engine's not working as hard. So it's almost like a proportional response. The faster and harder the engine works, the more the vehicle is going to move and the more air that can be used to cool down the oil within the oil pan. When you start looking at larger sized engines, you won't rely on air to cool down the oil any longer. The heat generated by the engine is simply too much, there's too much oil to cool down, and it's not efficient any longer to cool the oil using air. So what you'll use is an alternative system such as water. And you'll have a totally separate system for that, and the water would be pumped around this system and it will pass through a series of tubes maybe, and the oil will pass around the outside of the tubes and we will cool the oil in that manner. Obviously it's very important to ensure that the water doesn't mix with the oil, because if it did, that would be a big problem for the engine itself, because water itself does not have very good lubrication properties. So the purpose of a lubrication oil system, to lubricate and to cool. Smaller two-stroke engines do not have a separate lubrication oil system, simply because there are too many parts involved and it increases the weight of the engine by quite a lot. So rather than having a separate lubrication oil system, what you'll actually see is that the lubrication oil is mixed in with the fuel itself. If you have ever owned and operated a small two-stroke engine lawnmower or a leaf blower or anything like that, you'll know that sometimes they tell you to add 1 part lubrication oil to 100 parts of fuel oil, or 1 part lubrication oil to 50 parts fuel oil. It really depends on the age of the engine. So you're mixing the lubrication oil in with the fuel. As I've said though, once you get to larger engines, that's simply no longer possible. You need a separate lubrication oil system, and when the engine becomes even larger, then you're going to need a separate system to cool down the lubrication oil itself. So that's the first system out of the way. Let's go and have a look now at the fuel system.